Hello, this question is about Ergun's equation. The question is, the reactor of a catalytic reformer contains a spherical catalyst particles of diameter 1.46 millimeter. The packed volume of the reactor is to be 3.4 cubic meter and the porosity is 0.45. The bed depth is 40 centimeter. The reactor feed is a gas of density 30 kilogram per cubic meter and viscosity 2 times 10 to the minus 5 Pascal second, flowing at a rate of 11,320 cubic meter per hour. The gas properties may be assumed constant. The pressure loss through the reactor is restricted to 68.95 kilopascal. Calculate the cross-sectional area for flow and the bed depths required. Okay, so this question you can simply solve it by writing down the Ergun's equation. So from Ergun's equation, we know that delta P over L is equal to 180 times viscosity divided by d square times 1 minus porosity with the power of 2 divided by porosity with the power of 3 times velocity plus 7 divided by 4 times the density of the fluid, velocity square divided by the particle diameter times 1 minus porosity divided by porosity with the power of 3. Okay, so all of these parameters are given except Q, because we know the viscosity, that is 2 times 10 to the minus 5. We know the L, the depths, that is 40 centimeter. We know the rho F, that is 30 kilogram per cubic meter. We know the particle diameter, that is 1.46 millimeter. We know the pressure drop, that is 68.75, and we know the porosity, that is 45%. So if you plug these values into this equation, you get 68,750, that is the pressure, divided by depths of the divided by the bed depths 0.4, equal to 180 times 2 times 10 to the minus 5, that is the viscosity, divided by particle diameter, that is 1.46 times 10 to the minus 3 with the power of 2. Pay attention here, I'm working with the SI unit, so I convert it to the to meter, because the diameter was in millimeter, times 1 minus epsilon, that is 1 minus epsilon is 45%, that is 45 with the power of 2 divided by 45% with the power of 3 times Q, which is the unknown, right? Plus the second part of the Ergun's equation, that is plus 7 divided by 4 times rho F, that is given, which is 30 times Q2, which we don't know, divided by D, that is 1.46 times 10 to the minus 3, okay, times 1 minus epsilon, 1 minus 45%, divided by 45% with the power of 3, okay? So this is one equation with one unknown, right? Because here you have Q, you have Q2. So if you do the calculation here, you can simplify this equation to 17. Obviously, you need a calculator here. That will be simplified to 17, 18, 75 equal to 5606.407 times Q plus 2170 35.9 times Q2, okay? And this equation you can simply solve, and you can calculate the Q value as Q equal to 0.876529 meter per second. But remember, the question was about to calculate the cross-sectional area for flow, okay? So here you have the Q value, okay? What you should do here, now you know the volumetric flux, which is actually given here, that is the rate 11,320 cubic meter per hour. That is the volumetric flux. So we know that Q capital is equal to Q times A. And the question is about the cross-sectional area. Therefore, A will be equal to Q capital divided by Q. But remember, this is the unit of cubic meter per hour. Therefore, you first need to convert cubic meter per hour to cubic meter per second divided by the computed velocity. Then that will give you the area. So that means area will be equal to Q, that is 11,320, but I divide it by 3,600, okay, to convert the unit of cubic meter per hour to cubic meter per second, divided by Q. And Q you already calculated, which is equal to 0.876529. And if you do the calculation, you will get area A equal to 3.59 square meter. And that is the final answer.